All right, so we're beginning Unit 2, and Unit 2 is all about the derivative. In our previous unit, we talked about limits and continuity, and we talked about rates of change, and that being average rate of change and instantaneous rate of change. And in doing so, we use the formula, or not formula, but we use the expression the limit of f of x plus h minus f of x over h as h approaches 0, or if we knew specifically where we wanted to find the slope at a particular point, we used this version where a represented just an x value, so x equals a. So when we're talking about limits in terms of rates of change, when the limit exists, the slope is actually called the derivative. So you've been working with slope for a long time, it's at least from Algebra 1, if not perhaps in middle school in some capacity. But you've been working with the derivative. What you didn't know is that this concept of slope leads into this idea of a derivative. So a derivative from a calculus perspective is simply slope or a rate of change. Now the symbol that we use a lot is a little, it looks like an apostrophe, but that is, we read this as f prime of x. So let's talk about a definition of the derivative. So f prime at a is equal to slope, which can be found by finding the limit of this function as h approaches 0. And what that means is that the derivative of function f at a is the slope of the tangent line at x equals a. All right, there's another formula or another version, excuse me, for the definition for a derivative, and that is the limit of f of x minus f of a over x minus a as x approaches a. So this version here, if you really look at it and just kind of ignore the limit, I mean, this really looks like the slope formula. If you go back and you think about what this looked like, it was f of a plus h minus f of a, but technically what we did was we divided by a plus h minus a, and we noticed that the a's cancel. So I'm going to erase that. That just wanted to remind you of where the h came from. So putting this in perspective, let's say I have, I always like to use a quadratic. So if I draw a quadratic, if I have a point on this graph, which I'll call it 2, what either of these two versions helps me do is to find the slope of the tangent line at any given x value on the curve. So that's what, geometrically, that's what that looks like. Okay, so let's take a look at, let's go ahead and look at finding the derivative for a function f of x equals x cubed. And we're going to use, I want to use both definitions. So the first definition, when I want to find f prime of x, I'm going to use the limit. I'm going to use this definition first. And in this scenario, remember, a represents a specific number, but since I don't have a specific number here, I'm going to replace a, or simply use x for a in both of those. So I will find the limit of f of, f of x plus h minus f of x all over h as h approaches 0. Now what we recall from the last unit is that we need to substitute x plus h into x I need to evaluate f at x plus h. So we have our limit as h approaches 0. I will have x plus h cubed minus f of x. Well, f of x is x cubed. So I have x plus h cubed minus x cubed all over h. As a reminder, when you're finding a limit, no matter what the situation is, if you're finding a limit and you have a variable approaching a finite number, the idea for finding the limit is to be able to substitute this number, in this case 0, in for h and get a limit. Well, if you look at this, when I substitute 0 here for h, I get x to the third minus x to the third, which is going to give me that 0, and then 0 in the denominator, so that gives me that 0 over 0, which means do more work. Okay, so I'm always going to remind you that about limits and what it is you're trying to do. So I'm going to go ahead and expand x plus h to the third. I'm going to put what that expansion is. If you need to go to the side and write it out 3 times, x plus h times x plus h times x plus h, and then multiply it all out, that's fine. But the result of it, multiplying all 3 of those together, is actually x cubed plus 3x squared h plus 3xh squared plus h cubed, and I need to subtract, this is my subtraction, x cubed, and all of that's over h, and h approaches 0. Now we've done this enough to know that we can kind of clean up some things. We need to do some cleaning up here. So let's see what happens. I've got my limit as h approaches 0. Notice that my x's, or not x's, but my x cubes are going to cancel. And if you notice what's left, the 3 terms in the numerator that are left they all have an h common. So what I'm going to do is I'm going to go ahead and reduce or cancel an h out of all of these. And so what I'm left with is 3x squared plus 3xh plus h squared. That's what I'm left with when you reduce all 3 of these by an x. And so this is an expression now that I can substitute 0 for h and end up with 3x squared. Now, this is an expression that involves x. It said to find the derivative for this function. Well, we didn't find a derivative. We didn't find an average rate of change or an instantaneous rate of change for that matter at a particular point. So why then do we just have an x? And what is this really meaning? So f prime of x equals 3x squared. This is an expression that I can use to find the slope of the tangent line at any point on this curve. So putting it in perspective geometrically, this is a cubic function, and the graph of a cubic function looks like this. If I want to find the slope of a tangent line, let's say at 2. So if I want to find the slope of this tangent line at 2, all I have to do is find f prime of 2, and that will give me 12. So the slope of this tangent line is 12. And I can find the slope of a tangent line at any of the points on this graph. So let's say I wanted to find the slope of a tangent line at x equals 1/2. So what about f prime of 1/2? That would be 3 times 1/2 squared. 1/2 squared is 1/4 multiplied by 3, and you get 3/4, which if you picture the tangent line at that point, you'll notice that it is flatter than the tangent line at 2, and so this does make sense that this slope would be steeper than this one, or this number would be greater than this one. So this simply represents an expression for finding the derivative or finding the slope of any tangent line on that curve. So now let's look at it from a second perspective. Let's use this definition. So using this definition to find f prime of x, I will use the limit of f of x minus f of a, all divided by x minus a, as x approaches a. Okay, so now let's see what we've got. So this is going to have us take our function, which is x cubed, subtract the function evaluated at a, which will give me a cubed, and divide that by x minus a as x approaches a. So here we've got a scenario where we've got x cubed minus a cubed over x minus a, and we want to find the limit of that function as x approaches a. Well, when I substitute a here and here, I get the 0 over 0, so it's do more work. Please be careful how you simplify this. You cannot start slashing x's with a's. This is a difference of cubes, and a difference of cubes factors. You have to factor it. It factors into a binomial factor times a trinomial factor, and that's all divided by x minus a. My binomial factor for x cubed minus a cubed is x minus a. To get the trinomial factor, I'm going to take my x and square it. My middle term, multiply these two together and change the signs. So that would be plus xa, and then plus, I'll take my a and square it. And so I have the limit as x approaches a of, now when you look at what we have there, hopefully you recognize that our x minus a's will cancel. Now I can actually, I have x squared plus xa plus a squared. When I substitute a for x here and here, I end up with a squared plus a squared plus a squared, which ends up being 3a squared. So f prime of a, notice how these two are similar. They are, oops, I'm sorry. These two are roughly, or essentially the same thing. Okay, so finding the derivative involves limits, but it's using limits in the way that we've been doing for a while now. So now let's move on to the next example. So find the derivative for f of x equals the square root of x. Okay, I'm going to use first definition again. And so f prime of x equals the limit of f of x plus h minus f of x all over h as h approaches 0. And when I substitute x plus h in for x, I get the square root of x plus h. I have to subtract f of x, which is the square root of x, all over h. Okay, if I substitute 0 for h here and here, I get the 0 over 0, so I need to rationalize the denominator, not the denominator. I need to rationalize, but I need to rationalize the numerator. And that would be the square root of x plus h plus the square root of x over the square root of x plus h plus the square root of x. Okay, so I have the limit as h approaches 0. Remember, when you're rationalizing, when you're finding a limit and you're rationalizing, remember to multiply the conjugate pairs together. So the square root of x plus h times the square root of x plus h is x plus h. Since these are conjugates, the outside and inside terms, those inner terms are going to cancel. And so negative square root of x times positive square root of x is going to be minus x all over, I have the h, and I have the square root of x plus h plus the square root of x. Now in this cleanup process, notice that x minus x will cancel, and I have this h and h in the denominator. So this will actually clean up nicely to be the limit as h approaches 0. Now here's what you can't forget. What you're left with in the numerator is a 1. So I have 1 over the square root of x plus h plus the square root of x. And when I substitute 0 now for h, I ultimately end up with 1 over the square root of x plus the square root of x, which is 2 square root x. Okay. Once again, let's use the second definition. Let's use the other definition to see what it looks like. So the limit, we want to find f prime of x equals the limit of f of x minus f of a over x minus a as x approaches a. So this is telling us to take our function f of x, which is the square root of x, and subtract the function evaluated at a. So I have the square root of a all over x minus a. Well, this looks very similar to this. It's a little less complicated, but nonetheless, I still have to rationalize the numerator. So this time, though, I can get away with rationalizing by multiplying by the square root of x plus the square root of a over the square root of x plus the square root of a. So now what I have is the limit as x approaches a. Remember, multiply your conjugates together. Square root of x times square root of x is not square root of x, but it is x. The inside and outside terms are going to cancel since these are conjugate pairs. The square root of a times square root of a is a. So I have an x minus a over x minus a times the square root of x plus the square root of a. Now I have a binomial of x minus a in the numerator. I have a binomial x minus a in the denominator, and I can cancel them, and I'm left with the limit as x approaches a. 1 is in the numerator, and I have the square root of x plus the square root of a. And now I can substitute a for x, and I ultimately end up with 1 over 2 times the square root of a. So again, these two expressions are mostly identical. They are, for the most part, identical. So it's a matter of really getting comfortable with using these two definitions for finding the derivative, which of course is the slope. So I am not going to I don't necessarily want to talk about the geometric look at the two definitions. I don't think that's really necessary. But what I do want to do is, let's take one more example. And this time I want us to find f prime of 2. So if we use, let's just use the first, let's just use the first definition. So the first definition, I want to find, I'm going to wait and find f of 2. I'm going to substitute 2 when I finally get my answer. I guess I'll just show it more than one way. So I want us to find f prime of x first, and we can do, I don't know, f of x plus h minus f of x all over h. Oh, I left my limit off. And I can't tell you how important it is that you carry your limit with you. Okay, so here's what we've got. 2 times, got to put my limit as h approaches 0. I'm going to substitute x plus h into my function everywhere I have an x. So this is what it's going to look like. 2 times x plus h squared minus x plus h plus 1 all over 8. No, I have, and don't forget, oops, I have almost forgotten something very important. Minus, see, this is my f of x plus h. Now I have to subtract f of x. And so f of x is 2x squared minus x plus 1. Okay, so got caught up in what I was working on that I almost made a huge mistake. So, okay, I've got to square x plus h. So what I have is the limit as h approaches 0 of 2 times x squared plus 2xh plus h squared. And here's where this gets some people. You're subtracting both x plus h. So it's minus x minus h plus 1. And I'm going to subtract all of those. So I'm going to have a negative or minus 2x squared plus x minus 1. And all of that is over h. Unfortunately, this one has a lot of cleanup to it. Sorry about that. So the limit as h approaches 0, I will distribute the 2 onto this, and I get 2x squared plus 4xh plus 2h squared. Still have minus x minus h plus 1, and I have the minus 2x squared plus x minus 1, and all of that is over h. Okay, so let's see what we can slash. We ought to be able to slash quite a few things. I see a 2x squared and a negative 2x squared. I see a negative x and a positive x. I see a positive 1 and a negative 1. So what I'm left with is a limit as h approaches 0 of 4xh plus 2h squared minus h, so 4, and all of that is over h. And as we've done on every other problem, all 3 of these have an h that are common, so I can reduce each term by an h. So I'm left with 4x plus 2h minus 1. Please make sure that you know that that's a 1 and not 0. Now I can substitute my 0 for h, and my limit is 4x minus 1. This is the equation for the derivative, which allows me now to find f prime of 2. And that would be 4 times 2 minus 1, which is going to equal 7. So, whatever this graph looks like, I know it's let me pull this down. I know that this is a quadratic. It opens up, it has a y-intercept at 1. I don't know really. I could spend a little more time trying to figure out what the graph looks like. However, I know that at x equals 2, the point here at x equals 2, what I know is that the slope of the tangent line is 7. That's what I just found right here. Okay? All right. So, that particular approach was just as easy as anything. So using the definition of derivatives allows you to find the slope of a tangent line at any given point on the curve. Now, one of the things that we've talked about is that this expression represents a derivative, f prime of x. Since y and f of x are the same, y with a little apostrophe looking thing means indicates a derivative also. We read that as y prime. When you see d over dx, this is saying the derivative with respect to x. That's where the x comes into play. This expression, dy dx or dy over dx, is the derivative of y with respect to x. When we're working with a function, df over dx is the derivative of f with respect to x. And anytime, this basically says the same thing as the one above it. And these are different notations that we will be working with. So these are now fancy ways to represent slope. Okay, so I'm going to conclude this lesson now. You should be able to work on your assignment, and then we will look at lesson 2.